Good morning, everybody, and welcome to this other edition of Educall. Today, we're going to take a new chapter. So, for those new on this channel, please don't forget to subscribe because this really helps us and encourages us to produce the content for you. Please just subscribe. Just go. I'll hang on a minute for you to subscribe. Okay, I believe you must have subscribed at that time. Please do that. So we're going to take up hyperbolic functions. So we're going to take hyperbolic functions, which is a maths topic, or further maths better still. So we're going to proceed with knowing everything about hyperbolic function, knowing how the cos is changed to cos, how sine changes to sin, and their general expression in the form e to the x. So now we're going to take the introduction. So introducing, we're going to see how cos is changed to cos. Obviously, function is defined as a cosine of x, and it's obviously going to be abbreviated as cos x, and it has general formula half into e to the x plus e to the negative x. Same as for the sine, it's abbreviated as sine x, and it's equal to half to the e to the x minus e to the negative x. So the difference here is that here has a plus for the cos and here has a minus for the sine. So let's get deeper into. So now we're going to be seeing how to represent other hyperbolic functions because we have just represented cos and sin. What if you're given tan, cosec, and the others? So we're going to see how to represent them. So taking the sec, you obviously know that sec is equals to 1 on cos. That means it's just to reciprocate it, and you know that it's going to give me 2 on e to the x plus e to the negative x, and knowing that e to the negative x equals to 1 on e to the x, sorry for that, 1 on e to the x, which is, if we multiply all through the equation, we're now going to have 2e to the x on e to the 2x plus 1. Now we know cosec. Cosec is simply 1 on sin x, which is still going to be the same thing, the reciprocal, and which is equals to 2e to the x on e to the 2x minus 1. Now tan x is obviously going to be now what? Sin x on cos x, which now are now going to take the half. We're going to take half as on into e to the x minus e to the negative x as sin, and half e to the x plus e to the negative x as cos. Now the halves are going to go away. That means they're going to cancel out. They'll cancel out, and we're going to be left with e to the x minus e to the negative x on e to the x plus e to the negative x. You can express your tan as this, or preferably knowing that e to the negative x is same as 1 on e to the x, you could bring it in this form as I explained earlier by simply dividing. Now when you're having clothes x is obviously 1 on tan. That means we're simply going to be reciprocating tan that we had. Now reciprocating tan that we had, we're going to have a cos x on a sin x. That's obviously going to be what? Just changing the sign. That means the halves are still going to cancel. They will still cancel, and now we're now going to have e to the 2x plus 1 on e to the 2x minus 1. That means here you can still use this as your clothes x. So that was it for representing hyperbolic functions. Now let's now take hyperbolic identities, because we know obviously that in trigonometry there are identities that we knew as many, like cos squared theta plus sin squared theta equals to 1, like many other. So here we want to discover its own identities. Is it going to be same as trigonometry ratios or not the same? Now let's see this. What if we took cos x and sin x, but now they're telling us that this is equals to e to the x? Let's try prove that using a general solution. Knowing that cos x plus sin x is obviously going to give me this. This represents cos x and this represents sin x. So I open the bracket, I have half e to the x plus half e to the negative x, and then here plus half e to the negative x and half e to the plus half e to the x minus half e to the negative x. Looking at the terms closely, half e to the negative x is going to go away with this one, and we're going to be left with half e to the x plus half e to the negative x. That's going to give me e to the x. Hence the identity, wherever you see cos x plus sin x, always know that is e to the x. That's it for the identity. Now using the definition, evaluate this guy. This is going to be the second identity we're going to prove. Let's see what if we square cos x and square sin x, what are we going to have? Now this looks very familiar, like something like this. you know of this, the difference of two squares. That the difference of two squares is going to tell us what? Which is simply going to be equals to what? A squared. We're going to take what? A minus b, simply an a minus b, the brackets, into what? A plus b. Take it a plus b. That's simply what? Difference of two squares. So we're going to apply difference of two squares. That means we're going to have cos x minus sin x, and then into a cos x plus sin x. That's what I've applied there. Then for us going to go and it's still the same thing. If we go for expressing all of them and squaring them, we'll still come out to the same point. But here we're supposed to apply mathematics. We solve mathematics to be applied. So now we know very well from the previous question we had solved this one, cos x plus sin x, and it gave us e to the x. So we'll keep that. So what's now cos x minus sin x going to give us? Obviously, we know that we're going to be left with that. It's going to give us what? E to the negative x, because if we still get here and we cancel, this one is going to cancel with this one, is going to cancel with this one, obviously leaving us what? E to the x, negative x. Now we're left with e to the x to the multiplying e to the negative x. That's going to give us e to the 0, and e to the power 0 is 1. Hence cos squared x minus sin squared x equals to 1. Now this is unidentity. You see the difference between trigonometry and hyperbolic functions. There is the inverse. Instead is the plus sign x equals to 1, but here is the minus sign that gives us 1. That is for it. Now let's take these basic examples to actually exercise ourselves to see if we've really understood. So let's solve the questions that I'm going to give you. Now we have to prove here that what? 1 minus tan squared x is identical to sec squared x. 1 minus cos squared x is identical to cosec squared x, and sin 2x is equals to 2 sin x cos x. Let's begin. So solution 1, or to prove this. So there are two ways we can use to prove it. We can use by the definition of using e to the x, or we can still just manipulate it. So we're going to manipulate it, but we're going to solve it and send it to me in the comment section. You can send it to me to the comment section, or you can comment on more. So what we're going to have? We're going to have a 1. You know very well that tan squared x is equals to sin squared x on cos squared x. Now we know very well again that what? If we express this guy, that means we're going to have is cos squared x here. That's going to be a cos squared x multiplied with this. We're going to give me cos squared x minus sin squared x, all that on cos squared x. And from the identity we just had, cos squared x minus sin squared x equals to 1. This is the 1. And if we divide all through here, we're going to have cos squared x. And we know very well that cos squared x equals to sec squared x. That's as simple as that. So I want you guys to prove it and send it to me in the comment section. Now, solution 2 is telling us to prove 1 minus cos squared x is approximately the same as that. So we're still going to use the same thing. You know very well cos squared x is what? That's cos squared x on sin squared x. We're still going to be left with 1 on sin squared x. That's 1 on sin squared x, and 1 on sin squared x is equals to squared x. As simple as that. So as I said, I want you to use the general formula, general definition of e, and prove it and send to me. Now solution 3. In this solution 3, we're going to use e to actually do it, so that you guys see how I'm going to do it. So you know very well I'm proving. Therefore, I'm supposed to prove here that the right hand side of the equation is the same thing as the left hand side. So expressing the right hand side, that is 2 sin x cos x. I put 2. I write a general form of sin, that's e to the x minus e to the negative x on 2, multiplying with e to the x plus e to the negative x on 2. Now what do? I now do the multiplication proper, and I'm having e to the 2x plus 1 minus 1 plus e to the negative 2x. You see very well these ones are going to go away because they're going to give a 0. They're going to go away, so I'm going to be left with e to the 2x minus e to the negative 2x on 2. That is the right hand side. Hence, let's now go to the left hand side to see if it's going to give me the same thing. So solving this is obviously going to be half into what? E to the 2x, because this is its own coefficient 2x. So that's going to be e to the 2x plus e to the negative 3x, telling us that they are the same thing, just that I factor out the half here and I did not factor out the half here. So it's practically the same thing.